Okay, now we will try to see one example in F distribution to understand more properly. In previous videos, we understand what is meant by F distribution. Okay, let's imagine you are running one business in two locations, X and Y location, and you are producing cell phones. You are creating cell phones, for example. Okay, you got one doubt saying that in plant X, while creating the cell phone size, the size of cell phones created in plant X or size of cell phones created in plant X are greater than plant Y. That is your doubt. You got some doubt on this. So because this will ultimately leads to higher cost, right? To produce this small size also, this will impact your business. So you want to rectify this, whether it was true or not, whether you are creating the size of size of cell phone sizes of plant X greater than plant Y or not. So you took 20 samples, 20 cell phones from each plant X and 20 cell phones from plant Y. These we will call it as samples, right? So, and you calculated the variance of these in plant X. That value is 1.45, and in plant Y you calculated the variance that is 0.47. Okay, now our problem is we need to do analysis whether are we creating any bigger size in plant X compared to plant Y given 20 samples. Okay, this is our N and this is our variance S, S1, S2, and we know this whatever we are thinking, that is with 99% of level of confidence. Okay, see, this is our problem. Once again I will repeat. You are running one business in two locations, X and Y location. You are producing cell phones. Okay, you got one doubt saying that in location X we are creating bigger size cell phones compared to plant Y, location Y. To rectify, to clarify this, what we are doing is we took 20 samples, 20 cell phones from X location, 20 cell phones from location Y, and we calculated the variance in location X, that is 1.45, and same way location Y variance is 0.47 with 99% confidence level. Now we need to determine whether this claim true or not. Okay, to do that we are dealing with variance. We don't have any means as of now, so we will apply our F distribution formula here. Okay, so in this case our confidence level is 99%, right? That means 0.99. okay, then our alpha significance level is 1 minus C. Okay, then 1 minus 0.99 equals to 0.01. okay, this is confidence level and this value is the alpha. Now we know we are dealing with 20 samples, right? Then our N will be 20, right? Then we know we are given S1 variation is 1.45 in our problem, and S2 square is 0.47. So this data we are given, C, alpha and N and S1 square and S2 square. Okay, now as I earlier said, we need to know the degree of freedom of numerator and degree of freedom of denominator of first sample and second sample. So to determine F alpha, so F alpha will be what? F alpha will be this is our distribution, then f alpha will be this. So we should know what is the value of f alpha. Before we need to find what is the whether we need to reject or fail to reject our hypothesis. So to know the f alpha, we know degree of freedom of S1, degree of freedom of S2, right? So as earlier said, degree of freedom equals to first sample size minus 1. In both cases, if you observe, in our both cases we took only 20 cell phones, 20 sample size. Okay, then in our first sample 20 minus 1, and second sample size also 20 minus 1, that is 19 by 19. Okay, this is our alpha, f alpha. So once you know the degree of freedom of S1 and second sample, by seeing alpha f distribution data, f distribution table in statistics, we can know by seeing numerator or degree of freedom. In our case, our numerator degree is 19, right? So here 15 to 20, it will be in between these two, 15 to 20, and the same way denominator, ours is 19, 19 is here, so our value will be lies in this between, right? 2.6171 to 2.5089. Okay, this table you can get from Google or any statistics books. Okay, so now by seeing the table, I know the value is 0.274 3. This is our f alpha. This value we will get from the statistics table by seeing degree of freedom of the numerator and the denominator. So now we calculated f alpha. Now we know the variance of first sample and the variance of second sample, so that we can calculate the value of f. In this case, what is our first sample variance? 1.45 divided by 0.47. This value we will get f. Okay, so this value, as per f distribution, f distribution, if this value comes under this extreme towards f alpha, then we will reject our null hypothesis. Otherwise, we will fail to reject our null hypothesis. After calculating this value, what we determined is f, this value is greater than this value. Okay, once you calculate this value is greater than f alpha. That means this value comes under some value here. That means we got value, the probability of occurrence of this value lies under here. That means there is a chances of occurring this. That means f is greater than f alpha, right? That means we will say we are rejecting our null hypothesis. Okay, we are rejecting our null hypothesis. So what is our null hypothesis? I'm sorry, first you need to define null hypothesis and alternate hypothesis. Okay, what is our null hypothesis is, we are in plant 1 and plant 2, we are creating same size of cell phones. Our alternate hypothesis says mu1 is greater than mu2. That is what we thought, right? While seeing the problem, our null hypothesis says the size of cell phone created in plant X is equals to cell phone size created in plant Y are equal. Our alternate hypothesis. This is what our claim. Right? Our claim is what? In plant X we are creating bigger size of cell phones compared to plant Y. If you observe, in previous sessions I told you, if our alternate hypothesis says greater than symbol, then we will go for right tail test, right? This is what right tail test we are doing. So we are rejecting our null hypothesis. That means our claim is true, right? We are not creating same size of cell phones in our plant X and plant Y. Okay. So this is F distribution. Let me once again tell you what is meant by this example. You are running your own business in two locations, X1 and Y1, X location and Y location, and you are creating camera cell phones. Okay, but you thought that in location X we are creating bigger size of cell phones compared to location Y. Then what you done is, you took 20 cell phones from location X, 20 sample cell phones from location Y, then you calculated the variance of sample 1 X in location, that is 1.45, and in second location you calculated 0.47. Now we need to determine whether this claim was true or not with confidence level 99%. In this case, first, what is our null hypothesis? Our null hypothesis says in both locations we are creating same size of cell phones, but our alternate hypothesis, our claim is, we are creating bigger cell phone sizes in plant X compared to plant Y. So to start with that, we are saying confidence level 99%. That means our alpha will be 1 minus confidence. Locations we took 20 samples, so n will be our 20. Our first variance of our sample is 1.45, second sample variance is 0.47. These are values are already given. So we know F alpha, how to calculate F alpha, that F alpha equals to degree of freedom of first sample by degree of freedom of second sample. In our both cases, degree of freedom is 20. So 20 minus 1 by 20 minus 1, that will lead to 19 by 19. By seeing in F statistics table, numerator, denominator, you can find the value of this value, F alpha. Once you know this F alpha, this alpha is the same value. We will calculate it from statistics table. Once you know F alpha, then we need to see whether we given sample data fall in this area or in this area. If we got some value in this area, that means we are failed to reject our null hypothesis. If value comes under this extreme area, that means we will rejecting our null hypothesis. So to calculate F value, S1 square by S2 square, that is 1.45 by 0.47. Ultimately this value is greater than this value. That means this value lies under here, extreme. That means we are going to reject our null hypothesis. That means in both plants we are not doing the same size of cell phones. Okay, now you understood.